We shall now talk about the working of a computer based on something known as a block diagram or a functional block diagram of a computer. The word functional indicates explanation of working of a computer based on the function performed by each major component of a computer. At a very high level, the working of a computer is like this. Through the input unit, data and instructions are received. They are first run into the main memory. For the main memory, they ended up the secondary storage. From the secondary storage, as and when they are required, they are brought into the main memory. This thing in this block here, which says CPU memory, ALU, and control unit, is known as the central processing unit. It processes the data based on the specification of the instructions and then provides the output onto output devices like a monitor, printer, and so on. So this just gave you a high level view of how a computer really functions. But let's try to take a look which is a little more in depth to give you a better idea of the working of each unit. So the first unit which comes into picture is the input unit. Through the input unit, the computer accepts data and instructions. Examples of input unit are keyboard, mouse, scanner, mic. So through them, it accepts data and instructions. Once the data and instructions are provided, that particular information through the main memory is stored onto the secondary storage or secondary device. Now, let us say a computer has to execute or run a program. So that program as well as the data is retrieved from the secondary device brought onto the main memory. From the main memory, it is loaded onto the central processing unit. So the central processing unit consists of three major parts: the control unit, the arithmetic and logic unit, and the CPU memory. Let's take a look at each individual part in a little bit of depth. So everything which has to be executed by the CPU must first come into the internal memory known as the CPU memory, or also known as the registers of a CPU. There can be 16 registers, there can be 32 registers, and so on, each with the width or each with a capacity to store 2 bytes, 4 bytes, or 8 bytes depending on that particular machine. Now, once the instruction is interpreted, that means the meaning of the instruction is determined, then what happens is it proceeds to execute that particular instruction, taking the help of the other units to produce the desired result. So let's understand what is ALU. ALU stands for arithmetic and logical unit. So generally your program will contain a number of arithmetic operations like addition, subtraction, multiplication, division, as well as it can contain logical operations to find out if a statement like, say for example, is 20 greater than 30. This is a logical statement because 20 is not greater than 30 can either be true or false. So doing arithmetic and logical units, logical operations, is the function of this arithmetic and logic unit. But the major part or the most important part of the central processing unit is the control unit, because the control unit controls and coordinates the operations of all the hardware of the computer. So if you see the red dotted lines from the control unit end up going to the output unit, input unit, to the main memory, to the CPU memory, to the secondary, and every place. So if you see, the control unit tends to control the operations of every part of the machine. So now what does the control unit do? The control unit is like a monitor or a coordinator which controls and coordinates the operations of different hardware units of a computer. Now in the control unit does something like this. It first takes the memory instructions from the memory, dumps it into the CPU memory or the registers. It interprets or determines what is the meaning or what the instructions are meant to do. Once it understands the meaning of the instructions, then it directs the different parts to execute that particular instruction to achieve the desired goal or desired result. Now, the programs, before they have to be executed by the CPU, must reside. That means the program and data must reside in the main memory, also known as the RAM. This main memory is highly volatile in the sense when power is switched off, all the contents from its memory are lost. Information is stored in terms of zeros and ones, that is binary digits, also called as bits. Now, let us say I type in a program and data. It first from the keyboard enters the main memory. Then when I press the save button, it goes to the secondary storage. So if you see this green arrow, there is a two-way flow of data and instructions between the CPU to the main memory and then to the secondary drive. CPU doesn't directly talk to the secondary drive. Through the main memory, it accesses the contents of the secondary storage. So main memory contains data and instructions which are being currently processed by the CPU. Also, intermediate results of any calculations are also held in the main memory. Now, all the programs and data which are not being currently used or which are being stored in a permanently are in the secondary storage. Secondary storage is also known as an auxiliary storage. In auxiliary storage, you have data and programs which are stored permanently. The best way to understand auxiliary storage is think of your hard disk, pen drive, floppy disk, CD drive, DVD drive, flash drive, and so on. So these are all examples of secondary storage where data or programs are permanently stored. All right. So right now I have explained to you the different components. Let's take a look at what does the output unit mean. Computers process information in terms of ones and zeros. Obviously, humans are not trained to understand information in ones and zeros. So the output unit is used to display all the information in a human understandable form. Examples of output unit are printer, monitor, and so on. Now you need to understand these dots in this diagram. If you see the red dots from the control unit go to almost every part, indicating that the control unit controls and coordinates the operations of the different major units of the computer. Then the other part is you see certain blue lines. Okay, you see certain blue lines here as I'm moving the cursor. This indicates the flow of data. So when I type something, it comes to the main memory. Then from the main memory, it gets stored in the secondary storage. As and when you decide to run the program or execute something, it is taken from the secondary to the main memory. From the main memory, just a small set is taken into the CPU memory. It is processed and then the results are shown on the output unit. So just understand this particular block diagram because very frequently you will get a question. Explain the working of a computer based on the functional or block diagram. Functional means explaining the working of a computer based on the function of each unit. So you need to understand the function of each unit to be really comfortable to explain how a computer works. If there are 5 marks, you can be sure about 3 marks will be for the diagram and just about 2 to 3 marks will be for the explanation. So without diagram, this particular question has really no meaning.